So, if memory serves me right, next week, Friday, is Battle Royale. So that means the morning classes don't meet next week, Friday, which means none of the Algebra 3 meet next week, Friday, because we fall in that Battle Royale time frame. Okay? So therefore, we will have our next formative, again, formative, on Thursday of next week. Okay? So today we'll deal with geometric sequences. Monday we'll deal with geometric series. Wednesday we'll deal with applications of geometric sequences and series. Thursday will be a formative. Then the following week is another short week because it's an independent learning day Friday. So we lose out on 2 straight Fridays. And so because of that, we're going to test on Unit 7 on what day is that? The 7th of March. So the next 2 Thursdays, you have assessments. Okay? We will get you the homework packet for this section. We'll get you that on Monday, and that will be due on Thursday. Too. Okay? All right, so we did arithmetic sequences and series last week. And that was you added something to get to the next term. A geometric sequence or series is a sequence that has a constant ratio between the 2 terms, which means now we are going to be multiplying to get the next term. Adding is arithmetic. Multiplying is geometric. You gotta see what I mean here by basic idea. Yeah, multiplying to get the next term. Yep, exactly. That's what it means. Okay? So, here are some, sure they are. Here they are. Here are some examples of a geometric series. We're always multiplying by 2 in this one. Always multiplying by 2. We can multiply by a fraction. In this case, we're multiplying by 1/2. Okay? We can multiply by a negative number. Here now, we're multiplying by -2. Okay? So we can multiply by positive numbers, we can multiply by fractions, we can multiply by negative numbers, we can multiply by negative fractions too. Okay? The kicker is that to figure out that common ratio, okay, that common ratio, in a minute here we're going to call it R, step way outside the imaginary zone. Okay? To find that common ratio, we're going to take any term other than the first term, and we're going to divide it by the term before it. So we're going to take any term and divide it by the term that's right before it. And that's going to give us our common ratio. So what I mean here is like 16 divided by 8 is 2. That's where my common ratio comes in. 25 divided by 50 reduces down to 1/2. That's where the common ratio comes in. Negative 24 divided by 12 is negative 2. 12 divided by negative 6 is negative 2. Negative 6 divided by 3 is negative 2. Same with all of these. 50 divided by 100 is 1/2. 100 divided by 200 is 1/2. 32 divided by 16 is 2. Take any term divided by the term right before it. That gets you your number. Okay? So it helps if you write out at least 3 terms in your sequence. Okay? So the general rule, notice how the general rule has changed on geometric sequences. Thank you. Thank you. So that any term, and notice that we've switched from A's. We used A's in arithmetic sequences. We're going to use G's in geometric sequences. Okay? I know, but I will tell you this. That's helpful. Like when it comes test day, if it says G sub 1, that means we're talking about a geometric sequence. If it says A sub 17, that's going to be an arithmetic sequence. Okay? It's a little hint on that, okay? That you know which kind you're going for. Right? So any term or the last term that you're looking for is G sub n. Okay? That's going to be equal to the first term, G sub 1, times the common ratio raised to the number of terms minus 1. Okay? Right. I don't think there's anything else on this page. No, there's not. Move on. Sure, we move on. Now we move on. Okay? It says write the rule for the geometric sequence, then find G sub 7. Now, the nice thing too, Ms. Kirsch, is that we're not going to get like way out there. Like, you know, in arithmetic, we were talking like find me the 30th term, stuff like that. We're not going to do that in geometrics. You know why? They're either going to get super ginormous or really teeny, teeny, tiny. You know what I mean? Yeah. So we do like, however, I will tell you, we do love fractions. We don't like decimals. Okay? Love fractions, don't like decimals. Yep. All right, so first thing that I need, so the things that I need in order to find my rule are, I need to find my first term. In this particular case, what is my first term? 4. I need to find my common ratio. How do I find my common ratio? Any term divided by the term right before it, or what we multiply to get to the next term, right? Okay, 16 divided by 8 is 2. So R here is 16 divided by 8, which is just 2. Does that have enough information now? Is that all we need? Yeah, yeah. So my G sub n is going to be my first term, 4, times, now I would also strongly recommend that you put your R in a set of parentheses. Okay? And then that exponent is always going to be n minus 1. Now, classic mathematical mistake. What do you think most people, where they make a mistake, what do you think they do first if they're trying to find the 7th term? What do you think? It's a classic math blunder. We put 7 in for n, yes. But then, so when we're trying to find the 7th term here, so I'm trying to find G sub 7 now. what's going to be a classic mathematical mistake? Multiply 4 into 2. Can I multiply 4 into 2? Nope, I can't do that because the 2 is being controlled by the exponent. Okay? Which is why I love putting parentheses there around that r, to remind you that that's under the control of something else. Okay? So what is 7 minus 1? 6. So this is really 4 times 2 to the 6th power. 2 to the 6th power is 64. 64 times 4 is 256. Yeah. Love it. Okay. Let's do this rule now. Okay. What's my first term? 2/3. What's my r value? Which 2 do you want to use? Which 2? First and second, second and third, third and fourth. Which 2 do you want to use? First and second? Okay? So I'm going to take the second term and I'm going to divide it by the first term. Dividing fractions, all the way back to middle school. 3 words. Keep, change, flip. So I'm going to keep the 1/2. I'm going to change to multiplication, and I'm going to flip to 3/2. That makes this be 3/4. Is my answer. Okay? So my rule then, G sub n, is going to be 2/3 times 3/4 raised to the n minus 1 power. Seven minus 1 is 6. Ooh, now, how do I take a fraction to a power? Fraction to a power. What do you got? No, that's if we're dividing fractions. That's only if it's a negative exponent. I want to take 3/4 to the 6th power. What do? And I want to keep it in fraction form. Exponent rules, I know. Making you remember them all the way back from middle school. This was the basic of the basic. I shouldn't say the basic of the basic. That's adding. Lincoln, what are you thinking? What? Well, I know. And you know too. It's down there. I know it's in there. Mm-hmm. Mia, what are you thinking? Nobody knows how to take 3/4 to the 6th power? What are you thinking, Allison? Nope, that's only if we're adding or subtracting fractions. No. That was a good guess, though. At least that had to do with fractions, wasn't it? I don't know. So if we're taking the power of a fraction, because guess what, folks? You're going to be dealing with fractions this week, okay? I'm sorry, you're going to be dealing with fractions. You need to know this, that if you're taking the power of a fraction, that's the power to the top and the power to the bottom. Okay? Okay? All right? So what is 3 to the 6th power? What is 4 to the 6th power? Can I reduce those fractions before I multiply them? Well, is 4,096 even? Yeah, so it can be divided by 2. Is 729 a multiple of 3? Right? 729 divided by 3 is 243. So the 7th term is 243 over 2,048. I'll save you from asking the question. No, we will not accept decimals. We only will be accepting fractions. What's wrong? So, as long as it's on top and on the bottom, I can cross it out. Right? So 2 goes into 4,096, 2,048 times. 3 goes into 729, 243 times. Not like cross multiplying. They have to be top and bottom. They can't be top or bottom. One's got to be on top, one's got to be on the bottom. Okay? All right, so let's write rules given certain conditions. So we've got one term in our sequence. We've got the common ratio in our sequence. We need to find the rule. So here is any term somewhere in our sequence. Here is our common ratio. Our rule is that, I guess I did have it written, it was lost in the light up there. Okay? Our rule is that so this is saying that negative 16 is going to equal, I don't know what my first term is. I know that my common ratio is 2. I know that negative 16 is the 6th term minus 1. Six minus 1, 5. Two to the 5th power. Solving for g sub 1, negative 1/2. Did not ask us to find another term, So then our rule is going to be, our first term was -1/2 times our common ratio 2 to the n minus 1 power. Okay. With that being said, I would like you to now try letter D. I get 4/9 times -3 to the n minus 1 power. No. Oh, sorry, yes, it should be. I forgot I did just the negative sign there. My fault. Yes. Okay. Love it. Ooh. Writing a rule, another kind of condition, given 2 terms. Okay. So just like when we had it 2 terms given in the arithmetic world, we have to come up with 2 rules here, or use the rule twice. So this one is going to give me 48 equals g sub 1 times r to the 4 minus 1 power, or 48 is equal to g sub 1 times r cubed. Agree with that? Yeah? This one is going to give me 1,536 equals g sub 1 times r to the 8th power. Yes? Well, first thing you're going to do, you use the general rule in both terms. Second thing, solve the smaller exponent for g sub 1. Okay? So what I mean by that is, whichever equation has the smaller exponent. Which one has the smaller exponent? Blue or green? Blue has the smaller exponent. So I'm going to solve this equation for g sub 1. So I'm going to divide both sides by r cubed. Then I'm going to substitute into the other one. So I'm going to take 1,536
And that's now going to equal, instead of G sub 1, I'm going to say that that is 48 over R cubed times R to the 8th. I took what G sub 1 is, because it's got to be the same in both of these equations, and I plugged it in the other equation. Kind of like a substitution system of equations. Okay? That then gives me 1,536 is equal to 48 R to the 5th power. What would you do next? Wait. Because it's dividing. So this would be like 48 R to the 8th over R cubed. Right? More R's on top and more R's on the bottom. How many more? 5 more. And that's why we go with the smaller exponent. Because then that'll always cross out. Okay? Orange now. What will we do next in orange? Divide both sides by 48. Someone with a calculator, help me out. 1,536 divided by 48. I want to say 32. Now what? I want to solve for R. Fifth root of R. Everybody know how to take the fifth root on their calculator? Most of you have the same calculator. You got to take 5 first. Then it's the second of the exponent key. Then it's 32. Then it's equals. Should get 2. Then I'm going to take that and I'm going to put that back into my equation that I have previously solved for G sub 1. 2 cubed is 8. Yeah. So this is 48 divided by 8. 48 divided by 8 is 6. So my first term is 6. What were the 2 things that I needed? Nope, first term and the ratio, right? Just got them both, right? So my rule here is going to be G sub n is going to equal 6 times 2 to the n minus 1 power. Is that equal? I don't ever. Okay? Now, there is a special case in the given 2 terms realm. Okay? So let's set it up. So first step was, I'll give you, actually, I was going so excited, so jazzed up for this. I'll let you write it down first. G sub 4 is 48. G sub 10 is 3072. No, that's function notation. G sub 4. G of 10 is like a function where you're plugging 10 into a function. We're not plugging 10 into anything. Okay. Step number 1 from the last one was what? What do I do with G sub 4 equals 48? So give it to me. So that's going to be 48 equals G sub 1 times R cubed. Okay. What else do I have to do in step number 1? The other one? 3072 is going to equal G sub 1 times R to the 10 minus 1 power. 3072 is going to equal G sub 1 times R to the 9th power. Agree with that? Okay? Step number 2 from the last. Which one, blue or green? Blue? Okay. So I'm going to solve this for G sub 1. Then what do I do with that? Put it into the other one, put it into the green one. That's going to give me R to the 6th power. Correct the exponents. Exponent rule is coming back to bite us today. 3072 divided by 48. 64. What do you got, PFG? I thought you just told, or were you just flipping her off?
No.
Oh, okay.
A.
It is not 1.
No, I know.
What? No. You got 2, 2? Yeah. Still not 2. Or should I say, not just 2? Why plus or minus? Why plus or minus? Because we're taking an even root right here. Yes. So it's plus or minus 2. Now, you may be thinking to yourself, that doesn't matter. Yeah, it does. Because when you come back here to positive 2, then it's 48 divided by 2 cubed, which is going to be 48 divided by 8, which is going to be 6. Right? So that's going to give me g sub n is equal to 6 times positive 2 to the n minus 1 power as my rule, right? But when I come back here and I go negative 2, 48 divided by negative 2 cubed. What is negative 2 cubed? Negative 8. So this is 48 divided by negative 8, which is negative 6 as my first term. So this one could give me one of two rules. And both of them work because of the even root that we took. Both of those rules would apply given this scenario. So this one, this special case gives me two answers that I need to give. Okay? Something tells me that was the last. 'Twas